Okay, this is day 5, rational exponents and how they relate to radicals. So essentially, today's lesson is going to review some of the grade 9 exponent laws, as well as teach you the new exponent laws that you haven't seen before regarding, if the exponent is a fraction. So if the exponent is a fraction, we're going to figure out how that is related to radicals. But before that, we will take a look at some of these laws and do some quick notes on them. Now the first one, x to the power 1 equals x. That's pretty straightforward. It's just telling you that if you have one x, one term, it's just x. So anything to the power 1 is itself. Okay, anything to the power 1 is itself. The next one is a little bit different because it says x to the power 0. And it says that it's going to equal 1. If you look at the example, 7 to the power 0 equals 1. Okay, so this is just something you're going to want to memorize. We could do a quick little activity or pattern to sort of demonstrate why it's 1. And we can just do a pattern like this. Let's say we do 2 cubed is 8. Two squared is 4. 2 to the 1 is 2. So now let's take a look at this pattern. As we take away one term of x, you can see the powers are going 3, 2, 1. So essentially you're removing a term 2. You're removing a factor of 2 every time. So essentially all you're doing is dividing by 2, dividing by 2. So if you remove one more factor of 2 so that you end up with 2 to the 0, the next one in the pattern would be 2 divided by 2, and you get 1. Hopefully that pattern sort of demonstrates anything to the power 0 is 1. And yeah, like I said, make sure that you just memorize that one. Now the next two are related. Let's take a look at these two. These two are related. It's basically saying if you have a product with powers and it's the same base, if you're multiplying x times x, in this case power m and power n, x to the m times x to the n, you just have to add those powers. And likewise, if you divide rather than times, you just have to subtract those powers. So let's take a look at the example. X squared times x cubed, if you think about that, x squared is 2 factors of x, and x cubed is 3 factors of x. Now can you count them up? How many are there? There's 5 factors of x. In a similar way, you can think about the division. X to the 6, well, you would have to have sorry, I'm just having a little bit of a glitch here. There we go. You would have to have 6 x's up top. That's x to the 6. You can count them up. There's 6 of them. And then you're going to divide x squared. So that means there's 2 on the bottom. So now you can cancel because they're the same. And how many are you left with? 4. You're left with 4 of them. Or in other words, in the power, 6 take away 2 is 4. So these two guys are similar in the sense that they have to have the same base. If you're timesing, you're going to want to add those powers. If you're dividing, you're going to want to subtract those powers. The next one, this one here, this one's called power of a power. You already have a power, namely x to the m, and then you're going to raise it to the nth power. So here you can see that you have to multiply. It's m times n. Let's look at the example. So it's x squared cubed. So you already have a power, x squared, and then you're going to cube it. So the rule says, okay, 2 times 3 is 6. This is x to the 6. So why is that happening? If you think about that x squared term, that x squared term would be x times x. And you have to take that x times x and you have to cube it. If you're going to cube it, that means you have to write it 3 times. That's x times x cubed, because there's 3 of those terms. And now if you count those up, there are 6 of them. And the last two are related as well. These ones are often messed up by even students in later grades. What it's saying is that if you have a product and you raise it to a power n, you have to put that n on both terms. So it's like the n is being placed on both. And you have the exact same result with division. X divided by y in a bracket to the power n is the same thing as x to the n divided by y to the n. Let's look at those examples. The product xy cubed is x cubed y cubed. If we were to expand this one, doing what we did just before, you would have to cube xy. That means you got to write xy 3 times. Count up the x's, there's 3 of them. Count up the y's, there's 3 of them. Similarly, for the one underneath, you have x over y, and you have to square that. What that means is you have to write x over y twice. That's what squaring means. The power's 2. So then count them up. You have 2 x's up top and 2 y's on the bottom. So most of this stuff is a review from grade 9 exponent laws. We're going to be adding to this chart, 2 more rules eventually. So let's take a look. Why would they want us to review fractions? Oh my gosh. Why would they want us to review fractions? And I'll just give it to you now. What's going to happen is if, say you had something like this, 9 to the 1/2. What everybody can do now is just try to pop that into your calculator. So it would look like this in your calculator. 9 to the exponent 1 divided by 2. And then you get 3. That's interesting. So we'll come to see that fractional powers are related to radicals. This is actually the square root. The square root of 9 is 3. So there's something deeper going on here that we're going to have to visit later. So we have to be able to work with fractions. That's what we're going to do here at the bottom. The fraction operation review. So you have a half plus a third. You cannot just add a half and a third because they are different size portions of a whole. You need a lowest common multiple, which we've talked about in previous days. The lowest common multiple for 2 and 3 is 6. So 1/2, you would have to times this by 3, times this by 3. Whatever you do to the bottom, you do to the top. That keeps the proportion. And then you have the 1/3, which you need to get to 6. So times by 2, times by 2. Whatever you do to the bottom, do to the top. So you should have 3 over 6 plus 2 over 6. And altogether you have 5 over 6. Once you have the LCM and you've changed the denominators, then you can just add the tops. So 3 plus 2 is 5 out of 6. 5 out of 6. 5 out of 6. 3/6 plus 2/6 is 5/6. Alright. That's adding and subtracting of fractions. And multiplying fractions, all you have to do is go top to top, 1 times 1, and bottom to bottom, 2 times 3. And you get 1 over 6. So 1/2 times 1/3 is 1/6. That's the rule for timesing. You just go straight across the top and straight across the bottom. Now for dividing of fractions is difficult, so we just switch the divide to a times. In order to do that, you have to reciprocate the second term. And 1/2 times 3 over 1 would be 1 times 3 on top of 2 times 1. You have 3 over 2 as your final answer. So there's a quick review of fraction operations from junior high. Alright, so now, powers with rational exponents. This is new stuff for grade 10. You would have not have been taught this in junior high. So let's take a look at this equation and what it's telling us. Some base x raised to the power m over n. So the power is a fraction. How that will look is the power as a fraction will become a radical. Now how to convert that? The denominator of the fraction in the power, it will get put as the index of the radical. That's the most important part. The denominator of the fraction is the index on the radical. And then the x to the power m can just stay there. It doesn't matter which order you do it in. You can take the nth root of x and then raise it to the power m. It doesn't matter the order. As long as you get the nth power, or pardon me, the nth root, then you're good. So let's take a look at this one. 40 to the power 2/3. Just identify the denominator. This tells me it's going to be a cube root. For you guys in this class, like the denominator is always going to be like a 2 or a 3, usually. 2 or a 3. 3 is going to be the cube root, 2 is going to be the square root. So this is a cube root of 40 squared. Or I can take the cube root of 40, do that first, and then square the result. Either one of those is perfectly fine. You can do either one. Let's take a look at the next one. Now they want us to go from the radical to the power. So let's take a look at this. What's not written is a little 2 there. That tells you it's a square root. The 2 is not written. You just have to assume that it's the square root. So then this would be 3 to the 5, but with a denominator of 2. It's 3 to the 5 halves. 3 to the power 5 halves. The one beside it is a completely different question, so there's nothing relating these two questions. They just wanted to convert to a fraction power. So 25 is the base, but what's important is that you identify the index. The index is the denominator. So this is 25 to the power 2/3. The base is 25 and the exponent is 2/3. It's really bizarre to have like a fraction as an exponent, but just bear with us and we'll get through this. So they want us to find the exact value. So we got to get an answer without the calculator. So yikes. This looks crazy, but it is doable. So let's try it out. 27 to the 2/3. Identify that the denominator is the index of the radical. So this is a cube root of 27. And then once we get that answer, we're going to square it. The cube root of 27 is something you should know by now. That's just 3. We still have to square it. We get 9. All right, the next one is power 1/3. So that tells me that it's a cube root of -8 to the 1. Anything to the power 1 is itself. So this is the cube root of -8, which is equal to -2. -2 times -2 times -2 is -8. Taking the cube roots of negatives is okay. We talked about that before. Taking the square roots of negatives is not. So just be careful there. The other thing I want to show here is that for the first question, I did the cube root first and then I squared it. But in the second question, I did the power 1 first and then cube rooted. So it doesn't matter the order. Do you deal with the bottom first or the top first? It doesn't matter, as long as you do it separately. All right, this one is 25/4 to the power of 0.5. This question, they're just trying to mess with you. 25 to the 0.5. This is the same thing as 25/4 to the power 1/2. So we have to go back to that exponent rule that says if you have a quotient to a power, you have to put that power on both. So this is going to be 25 to the 1/2 and 4 to the 1/2. Yeah, it's on the previous page, so I don't want to flip back. But that is from the previous page on a chart. Now what I can do is I can evaluate these two powers separately. So this is the square root of 25 over the square root of 4. because the denominator of the fraction is the index. If it's 2, you don't have to write it. And if the power is 1, you also don't have to write it on the 25. Evaluating this, you get 5 halves. Let's keep going. Identify the index. It's going to be a 4th root. That's a little bit different than we're used to. And here I have options, like, could I do 81 cubed in my head? No. So I'm going to take the 4th root of 81 first. The 4th root of 81 is 3. That one might not be as obvious to some of you, but 3 times 3 times 3 times 3 is 81. And then 3 cubed becomes 27. You will have to do this on the test. You will have to show how to do this. You'll have your calculator though, so it's a bit of a different situation, but you have to show these steps. Like, you have to show this conversion, this simplification, and then this final answer. You have to show that to get the full marks. Now this one again is not entirely obvious if your number sense isn't that great, but you know that 0.75 as a decimal is the same fraction as 3/4. Like if you had 75 cents, you have 3/4. This is a 4th root of 16, and then I'm going to get that result and cube it. I don't know 16 cubed. 16 to the power 3. I don't know that in my head, so I'm not going to go that way. I'm going to take the radical first. The 4th root of 16 is 2. Because 2 times 2 times 2 times 2 is 16. I still have to cube this. I get 8. So again, some of you are probably like, well, Mr. Linerber, I could just put that in my calculator and then it'll tell me it's 8 right away. But then again, like, if you want to be able to do this properly, then you got to show your work. This is extension. We will leave this till I get back. Alright, let's take a look at these examples now. This will be a cube root of 27. That's 3. This will be a square root of 0.49. Now this one's a little bit weird because it's decimals. I wish they just gave you like 49. But I bet you're thinking to yourself, something to do with 7. So how about that, 0.7? I'm just going to actually double check on my calculator. Square root of 0.49. 0.7, yeah. Okay, let's keep going. This next one is a cube root of negative 64. Remember, cube roots of negatives, that's okay. Negative 4. Because negative 4 times negative 4 times negative 4 is negative 64. And I'm actually going to write that one down just to remind you guys that when you have an odd number of terms, you end up getting a negative. Because these two will make a positive, and then that's a negative. A positive times a negative is a negative. So cube roots, it's okay to have a negative radicand. Square roots and any other even indices for that matter, you cannot. And the last one, this is going to be the square root of 4 on top of the square root of 9. That's 2/3. So I went a lot quicker on those ones. Hopefully it's okay. Now the last one, this is some pretty basic stuff, but it's just like I need you guys to just make sure your formula work is there. So that's why this question is there. It says biologists use this formula. Okay, whoop-de-doo. B equals 0.01 m to the 2/3. Like, I don't care about the biologists and I don't care about this formula. I just care that you guys know how to use the formula. So it's, first of all, it's important that you understand that 0.01, that's a coefficient. The variable m is being raised to a power 2/3. So think about your input-output machine. The m is the input. So you input an m value and you will output the b value. And as long as you understand order of operations, then you're okay in this case. You have to take care of your exponents before you multiply. So do this exponent first and then multiply by 0.01. If you have a nice calculator though, you can type this in and it will work perfectly. So let's take a look at what they gave us. In part A, switch to the black pen. In part A, they've given us a body mass of 27 kilograms. Okay, and I'm just reading the question. It says B is for the brain and M is for the body. So they've given us, in this question A, they've given us M equals 27. So then I can calculate the output B as 0.01 bracket 27 to the 2/3. If you want to do this by hand, this would be more of a multiple choice question, so you could definitely do this one in your calculator. You would have the cube root of 27, and then you square that. The cube root of 27 is 3. 3 squared is 9. And your final answer is 0.09. Definitely probably could have put that in the calculator right off the hop. And I'm checking my calculator now, and we seem to be okay. Just as a word of caution, especially if people using the old calculators, when you hit that power button and you have a fraction in here, make sure you use a bracket. So it's like numerator divided by denominator. Make sure you put a bracket. If you have the nicer calculator, you don't have to worry about that. But if you got the TI-83, you gotta use these brackets. Okay, let's take a look at part B. Part B, it gave us a body mass. Oh, it's the same, input and output. So again, for part B, they're giving us 200. So in both cases, they gave us the input, and all you have to do is calculate the output. So in both cases, they want you to input the m value Now when I go to try to do this one, I'm thinking to myself, the cube root of 200, that's not easy to do in my head. So I'm going to just put this one into my calculator. 0.01, 200 power 2/3. Yeah, it's not a nice number. 0.34. Alright, so that's the end of the notes. This is your assignment. Thank you and good luck.